Hello. Today we're going to do a bit more on matrices. So let's see what we're asked to do. So we're given the following augmented matrix, okay? And we're asked for what value or values of K does a linear system corresponding to this augmented matrix have no solution, infinite solutions, or a unique solution? Okay, so let's write a few things out here. So linear system, that's the same as system of equations. System of equations. It's just another way of saying system of equation. And what else? Again, we have this is our augmented matrix, so it represents some system of equations, and we're looking for the values of K, such that we have no solution, infinite solution, or a unique solution. Okay. So how should we start? So I think the best way to start is to row reduce our augmented matrix. Let's start by row reducing our augmented matrix. Always a good, whenever you see a matrix, usually a safe bet that you have to do some row reduction. So let's do this. Okay, so let's multiply the second row by -2. First row just remains as is. Second row becomes -2, -6, -2k. All right, so now scroll over a little more. Let's add the first row to the second row and see what happens. We get 0, k minus 6, and -1 minus 2k. All right. Okay. So do we really need to row reduce anymore? I'm not sure, but let's go back to the questions we're asked. And that might help us decide if we have to do any more row reduction. So our first question is hard to get to. We want no solution. All right. So if we go back to our row reduced form of our matrix, if we have no solution, that means that, let me use a different color, k minus 6 will equal 0, and -1 minus 2k will not equal 0. So we'll end up with something peculiar. So we'll get k equals 6. So we'll need k to equal 6. And if we put k equals 6 into -1 minus 2k, what do we get? -1 minus 2k times 6. This equals -1 minus 12. -13, this does not equal 0. So this will give us a situation when we have 0 equals a number. That doesn't make any sense, so therefore we have no solution. So therefore, when k equals 6, we have no solution. Okay, so now part B, infinite solutions. Let's pick another color. Part B. In order to have infinite solutions, we need the entire second row to be 0. So we have 0 equals 0. So we need k minus 6 equals 0. Or, sorry, that's not true. Let me think about this. Yes, I was going to say we need k minus 6 to equal -1 minus -2k, but that's not enough. We need that entire second row to be 0, because if our second row is 0, then we know one of our variables is going to be a parameter, or we'll need to take one of our variables as a parameter. And the only way that's going to happen is if we have one row of zeros when we reduce to reduced row echelon form. So we need k. This might be difficult. This may not be possible. I don't think this is possible. Not possible. Why? Well, if we want k minus 6 to equal 0. This implies k equals 0. K equals 6. Negative 1 minus 2k equaling 0 implies k equals negative 1/2. It's not possible for k to be both 6 and negative 1/2, so therefore it's not possible to have infinitely many solutions. Interesting. All right, so finally, let's see when we have a unique solution. I think that's part C. Part C, we want a unique solution. Let's pick another color. So C, unique solution. Let's go back to our reduced form. So if you want a unique solution, for a unique solution, we need k minus 6 not to equal 0 and negative 1 minus 2k not to equal 0 either. Okay, so scroll over here. So k minus 6 does not equal 0 and sorry, negative 1 minus 2k does not equal 0. Okay, so therefore k, that's not, so k cannot equal 6. That's not entirely true. We can let or not equal 0. So the only value k cannot be is 6. It's possible, so let's go back. Getting a little confused here. So if we go back to our reduced echelon form of our matrix, or reduced form of our matrix, in order to have a unique solution, we need a situation in the second row where we have a number equals something. So we at least need a 1 there. So we have a number. We need to be able to row reduce to something of this situation. The only thing that is an absolute must is we must not have k minus 6 equaling 0. Anything else is possible. So we can have negative 1 minus 2k to equal 0, or negative 1 minus 2k cannot equal 0. It doesn't matter. The only thing that is enforced is k minus 6 cannot equal 0. And the only way this happens is if we ensure k does not equal 6. So let's review. So we have an augmented matrix, and we need to find the values of k such that certain things are satisfied. First thing we do is we row reduce our matrix. So we did this, we multiplied the second row by negative 2, and then we added the first row to the second row, and then we just stop there. Not much else we can do. For no solution, we need the situation when we have 0, 0 number in the second row. So the only way that's going to happen is if k minus 6 equals 0 or k equals 6. Good. And of course, negative 1 minus 2k does not equal 0. So, and this is the case when k equals 6. So we're fine there. Now in the second situation, we want an infinite number of solutions. So when does an infinite number of solutions occur? It occurs when the second row, so when we have this situation, all zeros in the second row. So the only way that's going to happen is if both k minus 1, k minus 6 and negative 1 minus 2k, if both equal 0. Okay, so how is that possible? The only way that's possible is if k equals 6 and k equals negative 1/2, but it's not possible for k to equal 2 different values at the same time, so it is not possible to have an infinite number of solutions. Finally, we're asked for a unique solution. So when does a unique solution occur? A unique solution occurs when we have this situation. So we have a 1 in that last entry in the bottom row. So the bottom row is all zeros, a 1, and some number. So this occurs when we go back to our matrix. This occurs when k minus 6 does not equal 0, or when k does not equal 6. Our negative 1 minus 2k can equal any value, 0 or non-zero. We just have to ensure that the entry in the second last column at the bottom does not equal 0. And that happens when k does not equal 6. Good. So this brings us, I believe this brings us to the end of our session today, an end of matrices for now. Whoops. If you have any questions, send us an email at, there it comes, info@raisemymarks.com, or give us a call day or evening, and we'll be happy to answer any of your questions. Thank you for watching, and we look forward to seeing you soon.